Hello, hi. I'm going to make a quick little video about example 4 from the PLE. There's a question on the discussion board about it, and I think it's a really good example for us to go through. So let's go ahead and get to it. Alright, so in this example, they're talking about cumulative distribution functions. The question in the Blackboard right now, in the discussion board, actually has to do with the probability distribution function. So let's start here, and then sure, why not? Well, we'll just go through the entire example. Why not? So, okay, so let's go ahead and start with this. This is the probability distribution function, meaning you give me an x value, I tell you the probability of observing that x value. Okay, this is a discrete probability distribution function, and why is that? Because when you're choosing, so like 4, choose some number, this number needs to be it has to be a count, 0, 1, 2, 3. Actually, 4 choose something needs to be 0 through 4, right? But if we look here, 3 minus x, if you put 4 in for x, then get 6 choose -1, and that's not okay. So actually, what can x be? X can only be 0, 1, 2, or 3. Because of this combination here, we get limited by what x can be. Okay, so 0 through 3, so it's discrete. All right, first thing I want to do is describe this distribution function with a table. Okay, so alright, so all the different values of x, we have 0, 1, 2, and 3. So I'm just going to figure out what is f of x for each of those different possible values of x. So the way I do that is I plug in 0 here. Okay, 6, basically 6 choose 3, because 3 minus 0 is just 3, and then 10 choose 3. Okay, 4 choose 0 is 1. You want to go and use your combination formula and practice calculating that. Go for it. 6 choose 3 is 20. 10 choose 3 is 120. Okay, so this comes out to be 1/6. Now, the person in the discussion board who was talking about this said, why is it that up here we recorded it as 5/30? Well, actually, that doesn't matter. I can record it as 1/6 or 5/30. They're both the same number. So, just for the sake of argument that they're the same thing, let's go ahead and record this as 1/6. Okay? You'll see why they've recorded it as 5/30 here in a minute. For f of 1, we would go ahead and we would plug in 4 choose 1, 6 choose 3 minus 1 is 2, 10 choose 3. Okay, so this is 4 times 15 over 120, which comes out to be 3/6, which is 1/2. Okay, so I can record that as 1/2. For f of 2, same thing. 4 choose 2, 6 choose 1, over 10 choose 30. I get 6 times 6 over 120, which would be 36. So that'd be, let's see, that comes out to be 3/10. All right. And then lastly, f choose 3, so 4 choose 3, 6 choose 0, 10 choose 3. 4 choose 3 is 4, 6 choose 0 is 1, all over 120. That cancels, that's 1/30. All right. Alright, so this is exactly the same table that they show on the PLE, it's just my fractions are reduced, which is fine because, like I said, 5/30 is the same thing as 1/6, so it doesn't matter how I report it. Now, let us go to the first question. Question A, which said, what is f of 2? All right, so this is the cumulative distribution function evaluated at 2. Notice the capital F versus the lowercase f. Lowercase f is probability distribution function. Capital F is the cumulative distribution function. Okay, so this is the same thing as the probability x is less than or equal to 2, which less than or equal to 2, that would be all three of these. 1 over 6 plus 1 over 2 plus 3 over 10. Now, how do I add fractions? To add fractions, I must have the lowest common denominator. Okay? And then I would add the numerators. So what is the lowest common denominator? It looks like it's 30. So this is 5 over 30 plus 15 over 30 plus 9 over 30. 29 over 30. Now you see why they just, in the PLE, decided to leave everything over 30 so that when we were adding, we could do it nice and easily without having to think through what is our lowest common denominator. Okay, so they just have the lowest common denominator all up in the table. It really doesn't matter. Okay, so let's go ahead and go on to B. F of 1.5. This is the probability x is less than or equal to 1.5. Okay, and let's see. What are values of x less than or equal to 1.5? 1.5 is between 1 and 2, right? So is 2 less than 1.5? No, only 0 and 1, so I have to add up those two. So this is going to equal the, this is going to equal 1/6, right? Probability x is equal to 0. And we would add that to the probability x equals 1. All right, I need the lowest common denominator. Here the lowest common denominator is 6. So that would be 1/6 plus 3/6, which is 4/6. All right, which reduce to 2/3. Okay, so there we go. Get the same answer that they got, 2/3 on the PLE. All right, let me go ahead and get another piece of paper. Part C. Let's see. Part C. Part C is asking for f of -3. So that would be the probability x is less than or equal to -3. By definition, that's what capital F means. And yeah, x can't ever be less than -3. It can't be less than 0. So that's never going to happen. So that's 0. Okay? Okay, lastly, let's go on to finding the CDF of f of x. Okay, so let's find f of t. All right, so I like to draw a number line when I'm thinking this through and put on my values of x. Okay, and so I want to make sure that when I'm figuring out what my CDF is, that I've covered the entire number line. Okay, so starting with t less than 0, so back here, and if t is less than 0, remember what is f of x, or sorry, what is f of t? It's the probability that x is less than t, less than or equal to t. But now t is some number less than 0, so it's less than or equal to some number that's strictly less than 0. So that would lead us to the probability would be 0 because for any values of x that are less than 0, your probability of being in that number is 0, right? Then, so I have an open circle there. Okay, so then next I'll go from 0, include 0 this time, all the way up into 1. So include 0, now go up to 1, leave 1 open. Okay, now what is the probability of being less than or equal to numbers that are strictly less than 1? So strictly less than 1, you're just going to have that 1/6. Okay, so now let's go up to 2. Let's fill in 1. Okay, so we go from 1, so t strictly less than 2. T is strictly less than 2, so not equal to 2, but strictly less than it. Then I can add up 1/6 and 1/2. So 1/6 plus 1/2. All right, and then have another interval here. Fill in the 2, go all the way up to the 3. So 2 less than or equal to, and then go up to 3. So let's see. Strictly less than 3. T is strictly less than 3, so that means it doesn't quite reach 3. So we got sum of all those. So 1/6 plus 1/2 plus 3/10. Okay, and then lastly, from onwards to infinity, fill in the 3 and then keep on going. So less than or equal to, so t is now greater than or equal to 3. Okay, so fill in the 3 and keep on going onwards. T is greater than or equal to 3. So now that'd be all of the sum of all of these. 1/6, 1/2, 3/10, 1/30. All right, I can simplify these fractions, and I should. So 0, 1/6. If we add up 1/6 plus 1/2, then we get 2/3. We've already done that. Okay. If we add up 1/6, 1/2, and 3/10, then we get 29/30. And then if we add on 1/30, then we get 1. Okay, and don't forget your support.